now discuss few basics and very important terms. The first one that we will study is your distance and displacement. So what do you mean by that distance and displacement? What is the difference between that distance and displacement? So obviously we know that. So let's say for example, you are at your home now and you want to reach to the school which is at point B. So obviously already you're getting late. So you have to just take the shortest route to reach your school. Fine. So this is one thing. And but at the same time, once you leave from the school, obviously you took the longer path so that you will reach for the home at your convenience. So definitely, so it's up to you that you can select any one of the path depending on your priority. So now, what do you mean by that? Your distance and displacement that we will see over here. The distance is, we will consider it as a actual path length. The distance is nothing but your actual path length. So this is again a very important say. So the distance is actual path length means definitely. So this is the school which is at point C. Yeah. So you're just going from this your A to B and then you're just going from again B to C. So you're just taking a little bit your longer path. Yeah. So you're going from A, you're just reaching to your friend's house. Again, you just pick up your that friend and along with him, you just reach to the school. So this is what we can say for this distance, which is your actual path length. Yeah. But then if on another day, so there might be possibility. So you will directly reach to the school. So this is the path that you can take, which is the shortest one. So that means I can say that. So this shortest path. So the shortest distance between the initial and final position. So that we are going to call it as a displacement. That we are just going to call it as a displacement. So definitely we will say that the displacement is the shortest distance. The displacement is the shortest distance between initial and final position. That is the shortest distance between your initial and final position. Yeah. So that is what we can say about the displacement. That is what we can say about this your displacement. So the same thing I have just shown over here with the help of that diagram also. So that total path length covered by the object, that we are going to call it as a distance. So one more example. So let's say this is from A to B. Again, I will say that. So the distance between that A to B is 100 meter. You left from A and reached to the point B. So which is 100 meter apart. So the distance traveled in this case is obviously 100 meter, which is the actual path length. So this is the case first. Now let's say again the case second, where I'm just leaving from A, I reach to the point B, which is at 100 meter. Again, I left from B and I reach at point C, which is at 20 meter. So then in that case, we have to just find what is the distance. So distance is again the actual path length. So which is from A to B, again from B to C, that we will say that obviously it is 100 plus 20, which is 120 meter. Again, if we just talk about the third case also. So for the third case, I'm just going from A to B. Again, I'm just leaving from B and I reach to the A again. So this is your 100 meter. So the distance over here that we will consider is 100 plus 100. So obviously which is 200 meter for this particular case. So this is how we can just calculate the distance. We will see one more few examples. So this is what we can say about the distance, actual path length. Now the displacement. The displacement is the shortest distance between the initial and final position. The same example, I left from A and I reach to the point B. So what is the displacement? So for this case, again, the displacement is obviously that is 100 meter. Again, the next case, again, I left from A, reach to the point B. Again, I left B and reach at point C, which is at 20 meter. So what is the shortest distance now? Definitely this total is 100 meter. So the shortest distance between initial position is A and your final position is C. So this is your 100 minus 20. So obviously the displacement is 80 meter. The displacement for this case is 80 meter, which is different from than that of your distance. Why? Because we have just changed the direction. I just came in the opposite direction, and because of which the distance and displacement gets changed. And in the third case, again I left from A, again I reach B, and again from B to A. So again if I reach at A at the same point from where initially I left, so the displacement, the initial and final position is same. There is no distance between them, so the displacement is 0. So the displacement is 0 when the object is going to reach at the same point again. So that is what we can say about the displacement. So the shortest distance becomes 0 for that particular case. Then I will say that the displacement becomes 0. So this is the few things about your that distance and displacement. One more example that we can just consider. Let's say for example, this is nothing but the circle on which I'm just standing at point A. Now I'm just moving along the circumference of circle, and the radius of the circle is R. If I left from A and again I reach to the point A, so the distance traveled over here is nothing but your 2 pi r. Obviously that is the circumference of entire circle, which is 2 pi r. And then the next thing which you have to calculate, which is nothing but your displacement. Then displacement, since initial and final position is same, then I will say that, so definitely which is 0, the displacement will be 0. So this is one case. Then I will say that for the next case, let's say this is the point A and then this is the point B. Yeah, so obviously now I am just going to move along the circumference of circle. So this is the actual path along which I am traveling. Again, this is the circle of radius R. So you're going from A to B. So what is the distance? So obviously the distance is actual path length which you're moving along this circumference of circle, which is half of that total. So that total is 2 pi r, half of that is pi r. So the distance is pi r. Again, if you talk about the displacement, we will say that it is nothing but the shortest distance. So this is r and r. So the displacement will be 2r. So the displacement is 2r for this particular case. Again, there is one more third important case. So where I'm just saying that, so let's say I just left from A and I reach to the point B. So this is what I had shown, that this is a quarter of your that circle. So now what is that distance again? So again, that distance we will say that, so which is 2 pi r. So that is your 2 pi r upon 4. So obviously which is pi r by 2. So that is the distance. And again, the next thing that we will talk about, the displacement. So the displacement is the shortest distance. The displacement is the shortest distance. So A and this is B. So just connect these 2 points. Yeah. So just connect these 2 points. So this is R, this is R. Now you have to just find the length of the shortest path. Obviously that is according to the Pythagoras theorem. So which is R square plus R square, which is 2r square, and then I will say that it is a r into root 2. So that is the displacement for this particular case is the r root 2, and the distance is pi r by